The next question is here, that is question 3, and yeah, this one was a bit, we had to do a lot here to finish this one, so I'm sure you are curious to know what the answers are here. So to get started, let's talk about what was given, Q or B being the diameter of the circle, which means we're going to use perhaps angles in a semicircle somewhere because it's the diameter is given. Maybe some angles at center will be twice angles at the circumference, we do not know. PR is equal to QB. PR and QB are parallel lines, brings to life alternating, corresponding, co-interior, all those reasons can come in. QB is perpendicular to RS. So here, reminds us of Theorem One, I should think. So Theorem One is the one, the line from center, perpendicular to chord, so it's what we have here. We can easily deduce that this from here to there, it should be equal to from here to there, of course. Let's see what is going to happen here. We were given 25 degrees at PBQ. Let's find it. PBQ. This angle was given to us, and it was given as 25 degrees. Let's write that down before we forget. So this must be 25 degrees. I have a feeling there must have been a letter over there. I'm going to put a letter, whichever one I feel like, if I fail to find which one it was. Okay, so let's see. The first question, we were supposed to determine 3 other angles that are equal to 25 degrees. So now that we know that this angle right here is 25 degrees, we should at least be able to find all the other angles that are equal to 25 degrees. So let's see if we can get started. Firstly, what I want you to appreciate is this Z here. They are alternating angles. Are you seeing the Z I'm working with? Right there. So if you're looking at it, this angle and that angle over there should be equal. So let's write P1 first. So angle P1, as you have noticed, I numbered my angles 1, 2, 3 and so, unlike in the original question, here it's better to name our angles like this. Alright, so I'm gonna say P1 is equal to angle B, which was given to be 25 degrees. We know these are alternating angles, and this is mainly because PR was given to be equal to QB. That's sorted right there. So we've got one, just 2 other angles. I'm sure you'd use different methods, but I am going to do this. Look at RB. Notice is the arc that is subtending P1. And this same RB is subtending angle Q2 on the circumference as well, which means we have a subtle bow tie right here. We're going to highlight it, but today I don't have many colors. So here, this angle and that angle are subtended by arc RB. So they are also equal because they are angles in the same segment. So I'm going to write Q2 is actually equal to P1, which we have already proved to be 25 degrees. These are angles in same segment. Okay, that should be fine. Let's put 25 degrees here. We don't want to forget to write things that we have already calculated. Right, we still need one more angle that is equal to 25 degrees so we can finish the sum. And of course, it's over here. You see, OR is definitely equal to OQ. So let's write that one. OR is equal to OQ. And of course, I know you're saying it's the radii of the circle. And because those 2 are equal, we can now just agree that R2 as well should be equal to, let's say, Q2. These are angles opposite equal sides. And of course, you are noticing how R2 is also going to be equal to 25 degrees, aren't you? So this will be the other 25 degrees that we've got right there. So we were asked to find 3 other angles that are equal to 25 degrees. We did. If you found different ones, you should, of course, comment on our group and figure out. I would like to see which ones you got as well. So here is number 2. Now, number 2, we have to find R or B. So let's go and try to see which one that angle is. R or B. In our diagram, R or B, we just simply named it R or B. We named it O1. So we would like to find O1 quickly. This is the angle we want. So how can we get O1? Well, there are many ways of doing it, but I want you to see this triangle right here. Let me use the blue color if I find it soon. Just a minute. Right. Look at this triangle here. This one. That one. That triangle over there. If you look at this triangle, this line carries on like that. And if we have a line that carries on straight like that, it means that we are creating what we call an exterior angle of a triangle. And from what we know, the exterior angle of a triangle is equal to the sum of the opposite interior angles. So this angle right here will be equal to the sum of these 2 angles, that one and that one. Of course, we should remember that one. So I'm going to say O1 is equal to Q2, we named that one Q2 plus R2. This is an exterior angle of a triangle which is equal to the sum of opposite interior angles. Like that. That is a good reason for that. So let's have O1 quickly. You know that Q2 is given, we calculated that one to be 25, and we also calculated that one to be 25 degrees. You know, at times I just do this in a straight line, although you should just put it down here, you know, the formalities. Okay, that is this angle, that is R or B right there, 50 degrees. So let me put it there, so we won't forget that we have it. We calculated this one to be 50 degrees already. Then the next one is ORT. Let's find it. O, R, and yes, now I know this was T in the question. This is T right here. So we would like to find ORT. So our ORT is equal to R3. We want to find R3 actually. So how are we going to find R3 where it is? How are we going to find it? Let's see what you are going to do. But here in this triangle, you will find it's very simple. The triangle that we have here, there is 50 degrees we already have. This 90 degree was given. So if we were to work in triangle ORT, that's the triangle I'm working in. So if I call this one T1 and T2, I may not need really. This is just me explaining. This one was given. And of course, O1 is already 50 degrees. We proved this one. So it leaves us with one thing. It leaves us with R3. So I can easily say, well then, R3 is, you subtract these two from 180, and you should get 40 degrees over there. And this is sum of interior angles of a triangle. Like that. So this one is 40 degrees. This angle right there, 40 degrees. Okay, copy this if you must. Copy as fast as you can. We don't have much space, so I'll have to erase this part. However, in the meantime, please notice we are going to now calculate ORT. Oh, that's the one we just finished. So we're going to ROS. ROS. So in this next one, we want to calculate this whole angle right here. You know, there are two ways of doing it. If you remember from our Theorem One, if we have these two triangles, this one, ORT, we know it will be congruent to OST. Those ones are congruent triangles, you know, radii, common side, and of course the 90-degree angle right here. So you can use that one as well to find ORT. In other words, to find rather ROS. In other words, if this is 50, that should be 50 degrees, and that will make it 100. You can use that method. However, the one that's very easy to write is the one where we calculate S2 instead. It's faster. Easy on the pen. So what I'm saying is, I can easily now mention that, let's do number 4 here. I can first of all mention that OR is equal to OS, which is the radii. You know, good manners are very important. You don't want to make assumptions, because we will never assume that you know. We'll only mark what we see. So OR is equal to OS, that's the radii. What it means is that S2 is going to be equal to R3, which is 40 degrees. Remember, that's what we just finished calculating. So these are angles opposite equal sides. Right, if this is 40 degrees right here, you know, this is 40, this is 40. If I use triangle, this whole triangle, ROS, the whole triangle, this is the only angle that will be left. So I can easily go and say, well, therefore, ROS is now going to be 100 degrees. I just used sum of interior angles of a triangle. Of course, that should be simple to see. All right, then RPQ. That one, I think it's an interesting question. If I would like to hear from you, how many of you got it right on their own without checking? So we want to find RPQ. In other words, we just know that we want to find P1 plus P2 here, you know, that one. So it's a question, it's a matter of you calculating P2 only, if you want to count, because this P1 is already here, we proved it to be 25. And that is when we use our skill. P2 is equal to 90 degrees, people, and notice it's a diameter, this one, which subtends P2 on the circumference. I knew it was coming. Angles in a semicircle. This is the short reason we agreed to use, according to the department would like for you to use this one. So this one here is 90 degrees, right here. So if you want RPQ, then you better say 90 plus the 25 degrees. I would like to hope that it is 115 degrees. So this is question 3. So you can see it had a lot of lines and a lot of things over there, but I would like to think that you got this one right. And if you're getting it right, it means you're developing the skills that I need. If you didn't get it right, please try to do it again on your own, see if you understood the steps. That is all for this video. Let's go to the next one.